Hey, what's going on, guys? Let's look at this problem right here. This question is asking find the general solution to the differential equation, and here we have the linear second order differential equation with constant coefficient pattern. And if you look at this one and compare this one matches this one, right? So when we have this second order linear second order differential equation with constant coefficients, we can use this characteristic equation to solve for real roots. First of all, we have to find out our a, b, c values. In this case, a is going to be 1 because the coefficient here is 1, and b also 1, c also 1. So the characteristic equation is going to be r square plus r plus 1 is equal to 0. And if you see, this is not easy to find the real root, like we cannot factor or do anything. So what we have to do is we have to use this equation to find out the roots. And if you use this here, this x is r is what you are trying to find. So r is going to be negative 1 plus or minus square root of 1 square minus 4 times 1 times 1 divided by 2 times 1. And let's simplify this one and see what we get. Negative 1 plus or minus square root of 1 minus 4 divided by 2, and that's going to be square root of negative 3. Negative 1 plus or minus square root of negative 3 over 2. So here we are getting a complex number, right? So instead of putting this one, we can put an I square for the negative one. So the I comes out of this equation. So we get negative 1 plus or minus I square root of 3 and divided by 2. Now in this now this is a complex roots. So when we have complex roots, we have to use this equation to find out. This is going to be our general solution for this differential equation pattern. So we have to find out our alpha value and beta value. So we have to find the real number and the imaginary number. Now the real number is whatever the number comes before this plus or minus. Now to find that one out, we have to divide both by 2 and separate them. Let's continue this one right here. This is going to be negative 1 over 2 plus or minus square root of 3 over 2i. Now this is our real number, that's going to be our alpha value. Alpha is equal to negative half, and the beta values the value with I, that is root 3 by 2. So beta is going to be root 3 by 2. Now we can go ahead and write our final general solution for this differential equation. That's going to be y of x is equal to c1 e power alpha x. Alpha is negative half, so negative half x cos beta x. Beta is root 3 by 2, root 3 by 2x, and then plus c2 again e power alpha x, that's going to be e power negative half x times sine beta x. Sine beta is root 3 by 2 x, and this is going to be the general solution for this differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.